Hello everyone in CSC-121. This lecture is about dates and how to convert dates and work with dates. So it's interesting, I think, that I'm doing this date lecture on leap day of a leap year. So the leap day and leap year come from the Gregorian calendar, and you can see that the Gregorian calendar, which is the calendar that we use today, was developed in the Vatican. So the forerunner to the Gregorian calendar was the Julian calendar. And the Julian calendar was named after Julius Caesar. Now you can see that it was replaced it was introduced by Julius Caesar in 45 BCE and replaced by the Roman calendar. What they're talking about is the Gregorian calendar. Don't confuse a Julian date that we talk about in this lecture with the Julian calendar. They're two different things. So let's work with the QDate objects and classes, and you can find that material inside Module 4 of our class in Blackboard. And then in the section that's labeled PyQt5 Date and Time. So each one of these little items here is a program unto itself. So do you see how much I'm copying right here in this program? That is a complete program that you can copy to your clipboard and paste it into Tani and see how this stuff works. So I just pasted it in, and I'm going to call out a couple things to you. In the lecture on the Qt calendar widget that's in this chapter as well, you saw where we imported PyQt5 Qt core. Okay, there are several things in there that we're going to use here. In the calendar widget lecture, we used the constants that were in the Qt library, but we're also using the QDate class, the QTime class, and so on. So let's work with this and see how this program functions. So first thing that happens is this line gets the current date. So I told you that today was leap day. So today is February 29th, 2020. So this line right here is going to create an instance of a QDate class, and it's going to create this now object that has that date in it. Once we've got our QDate object instantiated here named now, we can then get the ISO date using this constant Qt ISO. We can also get the long date here, and we can also use the QDate and time class from Qt to get the current date and time. And once we have that, we can print out the whole thing. We can print out the current time, or we can print out the date from that QTime object. So let's run it and see what happens. Okay, you can see 2020 02 229. Okay, that came from this line right here. That's the ISO date with the year, the month, and the day. The next line that printed was the default locale long date, and that is this line. Okay. Next thing that printed was the QDate and time object output, and we created an instance of the QDate and time class, and it is created right. Let's see, created right here. Okay, where we get the current date and time, we populate it into this variable or object that we call date and time, and then here's that print, and that's what gets us this Saturday, February 29th at 1650, and it also prints the year in there too. Okay, so that came from this line. If we just wanted the time, here's the time part of it right there. Okay, so, and I don't think this last line printed. Don't think it printed at all. Let's comment that out and try it again. Yeah, so it did print. Sorry, this is the current time, and then the last one here was the Q time printed in the long format. So let me uncomment that so you can see that last line run. That's the long locale format right there. It gets us 4:52 p.m. Eastern Standard Time. Okay, so that's the first example. The one that I wanted to point out to you, now you should go through and read all of these. It talks about UTC time, which is used by pilots. If you think about it, somebody flying across the country doesn't, if they're talking to the tower or air traffic control or somebody, they all communicate in UTC time. They don't use local time, and so UTC time is one time for the whole world. So you can see what that looks like here. If we paste this code into Tawny, you can kind of kick the tires on the UTC time. Let's see if I can get this to clear out and paste in there. Okay, so here we're getting our local time right here. Now that's the local time, and then we're calling the UTC method, the toUTC method, to print out the UTC time. So let's look and see what the UTC time looks like. Local time is 1654. The UTC time is 2154. 2154. So you can see that it's actually a good bit in front of us. It's 5 hours. 5 hours in front of us. So, and then you can see it's given us a minus 8,000. Oh, it's behind us, sorry. The UTC time is behind us because it's a minus 8,000 seconds. So 18,000 seconds. So universal time right here, what the pilots use. Okay, another important thing in this lecture in Blackboard is you can do date arithmetic, and the QDate class has some really neat methods. You can see one here, days to now. So here's a little program to figure out the number of days from a date to another date. Let's put this into Tawny and run it. Okay, so we've got two Christmas dates that we're creating, and this is the way you can create a QDate instance of QDate with an arbitrary date. Instead of getting just the current date, we're actually making ourselves a QDate object that's for 2016 12/24, and here's 2017 12/24. So we've got two QDate object instances here, and then we're getting the current date. And so here we're seeing how many days have passed since Christmas of 2016, and here the next one is seeing how many days have passed since Christmas of 2017. So let's run this. Okay. There are 1,700 days too. So if we wanted to get this to this is how many days it's been. So let's look at this another way. Let's look at Christmas of 2020 and run that. Okay, there are 299 days until next Christmas. So I had to change the date here in order to get that logic to work right. And if we made this one 2021, you could see there are, let's see, 2021. Oh, that's days past. Okay. So, yeah. So, anyway, looks like this one is the best version of it. There are 299 days to next Christmas. How is that working if we take all this other stuff out? Let's see, Christmas 1, we get rid of that. So we have the current date in now. We have Christmas coming up for this year in Christmas 2. So I'm calling the days 2 method with the new date here inside the parentheses, and then we're printing out that it's 299 days until next Christmas. Sorry for the 2 dates in there, but I think days 2 is probably what they were trying to communicate. So let's continue on a little bit. Here's some using the add days method in order to do some date arithmetic. So we can try that out, the add days. So if we go back to our lecture here, or to our example here, we have the current date in now. Let's add 12 days, and then we'll print that out. So let's do this. Let's grab this code, and we'll put that code into Tawny and run it. Okay, so what's it doing? Well, it's printing out the current date as February 29th, Okay? If we add 12 days to it, that makes it March 12th, which would be right because today is the last day of February. So we add 12 days to it, it makes it March 12th. If we subtract 22 days from today, okay, it's the 29th, so if we subtract 22, it's February 7th. And you can also use it to add seconds, add months, or add years. So there's all the examples of how to do that. So another nice function that's built in here is you can find out whether we're in daylight savings time or not. Now currently we're not in daylight savings time, so let's see what this prints when we put this into Tani. Okay, clear the shell. Time zone is Eastern Standard Time. We're not in DST time yet. So that's right. Okay, the epoch date. Different computers have different operating systems. Different computers have different epoch dates. So I think I've got a web page up here on Wikipedia. Windows 10 is really based on the NT kernel. So if you're running Windows 10, the epoch date, the date that it actually saves dates as, is the number of the time since January 1 of 1601. Okay? Now that's different from Linux and Unix. With Linux, our epoch date is the number of seconds that have passed since January 1 of 1970. So different computers have different epoch dates, but that's what they're talking about, is the time that you started, or the date that you started counting from, the date and time that you started counting from. That's the epoch date. And we have a function to get the number of seconds from that epoch date. If we wanted to see here, I'm running Linux, so if I take this example and paste it in, that would get me my epoch date, number of seconds since my epoch date to be exact. So let's run this. That's how many seconds it's been since January 1, 1970 at midnight. Okay? So, epoch date. The last thing that I'm going to talk about, and there's more that I haven't talked about here, but I'm going to leave some for you. Military and space exploration, astronomy, still uses something called the Julian day. The Julian day. And when I first started writing programs, this is how we worked with dates. We would convert everything to a Julian day because it was real easy. Once you had this Julian day, you could just add 30 days to it and you would know exactly what the date was. What a Julian day is it's the count of days since the beginning of the Julian period. That is the number of days that have happened since noon on January 1st, 4713 BC. BC. That's a long time ago. So here's a program to get the Julian day for right now. It's using a QDate object, and it's just calling a method of the QDate object. So let's run this. Now, first thing you need to know is we're creating a now instance of QDate that has the current date in it. So this is going to be the current date. So this is going to print the Gregorian date, which is just our ISO date. It's also going to print the Julian day. So let's see how many days it's been since January of 4713 BC. That's a lot of days that have passed. Okay, you see it? 24/58/909. That's the Julian day for today. So anything that you have that's a QDate, for instance, the calendar widget returns a QDate to you. You could call the toJulianDay method to convert that date from the calendar widget into a Julian day. And that's all you wouldn't even need this code. This is how much code that you would have, is this one line operating off of whatever your calendar widget date class is that you returned. So that's how to get a Julian day. One last tidbit before we go. A lot of folks think that the star date that they refer to on Star Trek is a Julian date. It's actually not. It's, as you can see here, they're saying that star date 1207.3 is actually May 11, 2256. So we could write ourselves a function to figure out how many days, what the star date for today is, if we figured out the difference in days for this versus where we are right now. So anyway, a star date is not a Julian date. It's some kind of arbitrary date that they picked. And this is the first episode here that actually gave us a Gregorian date and a star date at the same time, where we could figure out what the star date was. So we've talked about Julian dates, we've talked about Gregorian, which is what we use currently, and we've also talked about epochs and star dates. So that's the end of the date lecture. Remember, the material on the Julian day will be helpful to you on the exam. Good luck.